EKC 222, Chemical Engineering Thermodynamics, application of the virial state of equations by Group 16. Historical development of virial equations of state. Originally, the virial equation derives its name from the virial theorem of Clausius. In this virial theorem states that in material system in a state of stationary motion, the time average of kinetic energy is equal to the time average of the virial. The virial theorem is independent of the particular form of the intermolecular forces. Hence, this theorem was further developed and related with the van der Waals equation. This equation interpreted qualitatively the deviations from the ideal gas behavior by assuming that the molecules were attracted to one another at large distances and repelled at a very small distances. His equation was then further advanced by Kamerlingh-Onnes. He tried to derive functions of the constants A and B in the van der Waals equation, but restricted it at very low temperatures. He introduced the second and third virial coefficient to enable a greater accuracy to model the gas behavior. Theory of the virial state of equation. Understanding the behavior of real gas. Deviation of the ideal gas equation. Virial coefficient. The virial equation applied for attractive and repulsive forces between gas molecules. Unlike the ideal gas equation, the deviations from ideal gas behavior occur due to high pressures or low temperatures in order to account for intermolecular interactions and molecular size. Virial coefficients express the deviation of the ideal gas law due to intermolecular forces, which represent the interaction between the molecules and temperatures. Virial equation of states. Virial equations. The equation of state of a substance can be expressed in a series form as follows. Virial coefficients. The virial coefficients of state with the functions of temperature are expressed as shown. As the pressure approaches zero, all the virial coefficients will vanish and the equation will reduce to the ideal gas equation of state. The pressure, volume, and temperature behavior of a substance can be represented accurately with the virial equation of state over a wider range by including a sufficient number of terms. The virial equation of state gives compressibility factor, Z, in the reciprocal molar volume, 1 over V. The derivations of the formula can be seen below. The virial equation of state gives compressibility factor, Z, in the pressure. From the virial equation in the pressure, B is the second virial coefficient, where B' equals B divided by RT. C is the third virial coefficient, where C' equals C minus B squared divided by RT squared, and D is the fourth virial coefficient, where D' equals D minus 3B, C plus 2B cube, divided by RT cube. First example. The pressure of methane in the reactor is at 5 atmospheres while the temperature at 300 Kelvin. Find the molar volume of methane if it in ideal gas, and in real gas if there is second virial coefficient, which is negative 0.002 liters per mole, and the third virial coefficient, which is 0.004 liters squared per mole squared. The solution is computed using MATLAB, which molar volume of ideal gas is calculated by PV equals nRT equation. Meanwhile, for real gas was calculated using virial equation, and the answer for molar volume is 4.9236. Question 2. Apply the virial equation of state for a 60% mole mixture of neopentane, 1 in carbon dioxide, at 310 Kelvin and 0.2 megapascal to calculate the A, second virial coefficient of the gas mixture, B, molar volume of pure neopentane and pure carbon dioxide. From MATLAB calculation, the second virial coefficient of the gas mixture is negative 0.0009 2 meter cube per mole, while the molar volume of pure neopentane and pure carbon dioxide is 0.011887 meter cube per mole and 0.012087 meter cube per mole. Application. You are a project engineer. You find a tank in your plant salvage yard which has a volume of 0.05 meter cube. The specs on the tank indicate that it will burst at 30 bar. Company policy is to never exceed half the bursting pressure of any tank. You would like to use the tank as a surge tank which will hold propane. The maximum amount of material to be stored will be 975 grams, and the maximum temperature will be 425 Kelvin. Will you be in violation of company policy if you use this tank? Perform calculations using the virial equation of states. Based on the calculation, no company violation occurs since the pressure is less than 30 bar, which is 14.9340 bar. As for non-ideal gas, between molecule A and B is intermolecular attraction, B of T, while between molecules C and D is intermolecular R repulsion, C of T. For ideal gas, PV equals nRT, while for non-ideal gas, PV per RT equals 1 plus B of T per V plus C of T per V square, and so on. Example of equipments that apply virial equation is high-pressure reactor. High-pressure reactor applies virial equation to prevent overstimulation of volume at high pressure. Distillation column can be applied to calculate pressure because it can calculate the vapor-liquid equilibrium calculations.